Okay, right. Now we know the formal definition. Let's get into the practicalities of it. First of all, we're going to look at y equals x squared, y equals x cubed, and y equals x to the 4 and see what they differentiate to. And I put different notation up. So sometimes you'll see y equals x squared and you write dy dx. Now, from the examples in the notes, we know dy dx is 2x. But there's lots of different ways to write dy dx, and instead of writing y equals x squared, you could write f of x equals x squared. It's just a different way of writing it, just saying that's a function of x. It's just a matter of preference. Some questions write it one way, some write it another way, some even swap between the two without even noticing. So don't worry about that, it's just a notational thing. So if you had it here, you'd write dy dx customarily. Here, if it was f of x, you'd write f dashed. That is dy dx, it's the derivative, and you write 1 dash to note differentiate once. So differentiating this, we know from the examples before, if we look at the notes, that this differentiated to 2x. And the other possibility is a little bit of mix of both approaches, is to write this notation, d by dx of x squared. Differentiate x squared, you get 2x. So I personally don't mind if you write it like this way, or like this way. As long as you write it clearly, whichever approach you like to adopt is fine by me. Although the question often tries to help you, lead you in a certain way to write things down. And I usually follow the question most times myself. So here, differentiating x cubed, we've done that before. So d by dx of x cubed then, we know that that worked out as 3x squared. We did that in the previous example. So we would write either d by dx of x cubed or dy dx or f dashed of x cubed is 3x squared. X to the 4, if we were to work that one out, we would actually get differentiate x to the 4, you get 4x cubed. And here it's the same thing, just different notation as we said above. So once you've started to do a few of these from the examples in the preceding section, we can work out a general rule. I hope you can see what happened. This is actually power 1, isn't it? So can you see what happened? This 2 came down to be at ground level, x to the 1 power less, wasn't it? And similarly, the 3 came down to be at ground level, x to the 1 power less. And here the 4 came down to be at ground level, x to the 1 less. So if you can, so it's actually true in general that formula, and it can be proved such. So if we adopt that with a general x to the n function, the n comes down to ground level, x to the power 1 less than n, which is n minus 1. This is the formula that we use to differentiate powers of x, and it holds, it always is true. And we've seen a few examples there to verify that it is correct, and it actually is in fact always correct. So here, using that rule then, let's differentiate y equals x. Now I'm going to, because it's y, I'm going to just write dy dx. So here dy dx is equal to, the 1 comes down, x to the 1 less than 1, which is 0. X to the 0 is 1, so it's 1 times 1, which is 1. So x differentiates to 1. And then this one, y dy dx, the 0 comes down. Lots of x to the 1 less than 0 is minus 1. 0 times anything is still 0. So when you differentiate x to the 0, which is actually the value of 1, it differentiates to 0. And if you were to draw that on a sketch just to illustrate it, y equals 1 is this value here. It's a straight line. So the gradient of that is a flat line, which is 0, which is what we've got. And it's the 0 all the way along the line, isn't it? Any tangent drawn at these points will be a flat line, won't it? Wherever you are. So the gradient's always 0. This one, let's differentiate that. So the minus 1 comes down to ground level, x to the 1 less than minus 1, which is minus 2. And we can tidy that up, minus 1 over x squared. That's the derivative then. Now the last example, y equals square root x. I've got it partially obscured here. That's actually, if you were to write that as a power, square root is power half. So simply then differentiating. The half comes down to ground level. X to the 1 less than a half, which is minus a half. Half take 1 is minus a half. So it's a simple process.